In this video, we're going to look at examples where we're asked to find the equation of a parabola given some information about it. So here's the first example. Find the equation in standard form of the parabola with x-intercepts 2, 0 and -1, 0 that passes through the point -3, 20. So first let's draw a little sketch. If we plot the x-intercepts, there's 2, 0, here's -1, 0. And if it's going to pass through the point -3, 20, which will be over here somewhere, then we can tell that the parabola is going to open upwards. So it's going to be something like that. Now, because we're given the x-intercepts, we're going to start in x-intercept form. And for 2, 0 to be an x-intercept, we would need x minus 2 to be part of the equation in x-intercept form. And for -1, 0 to be the other x-intercept, we would need x plus 1 to be part of the equation in x-intercept form. If you look at this equation as it's written right now, you can tell that if you replace y with 0, then you would solve for x being equal to 2 and x being equal to -1. The x-intercepts were given. However, that's not the only parabola that would have those two x-intercepts. You can imagine that if we made the parabola shallower like that, we could keep the x-intercepts there, change the vertex, change the stretch factor, and we would get another parabola with the same x-intercepts. Also, we could turn the whole thing upside down and increase the stretch factor, or just do one of those things. We could have a parabola like that, for example, same x-intercepts, but different parabola, so it's going to have a different equation. Therefore, the thing that we're missing here is the stretch factor out front, and I'm going to call that a. If I put an a there, then all parabolas of this form, where a is some constant, are going to have those same two x-intercepts. Our task now is to find the one that goes through the point -3, 20. In order to do that, we're going to sub in the point -3, 20, -3 for x, 20 for y, and solve for a. So we get 20 is equal to a times -3 minus 2 times -3 plus 1. And solving inside the brackets, we get a times -5 times -2 is equal to 20, or 20 is equal to 10a. Therefore, a is equal to 2. That means subbing that back in the original spot where we had a, the parabola that we want is y is equal to 2 times x minus 2 times x plus 1. By solving for a, we've found only the parabola here that we wanted that not only has x-intercepts -1 and 2, but also goes through the point -3, 20. We've pinned it down by finding the vertical stretch factor. We're not done yet though, because the question asks us to find the equation in standard form, and this is in x-intercept form. All we need to do then is expand. So if I do that, first let's expand inside the brackets. I get x squared plus x minus 2x is minus x, and then minus 2. And then I expand further, multiplying the 2 in, and I get y is equal to 2x squared minus 2x minus 4. So that's my equation in standard form of the parabola that was required. Remember again, the steps were we took the x-intercepts we were given, we put them into the equation in x-intercept form of this parabola, we let a be an unknown vertical stretch factor, we subbed in the point that we were given, and we solved for the vertical stretch factor. Let's do another example. This time we're given the vertex instead of the x-intercepts, but we're going to approach it in the same way. We're asked to find the equation in standard form of the parabola with vertex 310 that passes through the point 5, -2. So if I imagine my graph here, 310 we would put up there. 5, -2 is going to be down here somewhere, so I can tell that my parabola is opening downwards. So I'm going to expect that when I solve for my vertical stretch factor, it'll be negative. This time, because we're given the vertex, we're going to write this in vertex form. To have vertex 310, remember the vertex of our parent function parabola y is equal to x squared is at the origin. So I've had to move 3 to the right. So I replace x with x minus 3 squared, and I've had to move 10 up. So I have plus 10 at the end. So this is a parabola with no vertical stretch, or rather vertical stretch factor 1, that has vertex 310. But we don't know what that vertical stretch factor is, so again we're going to introduce another variable. We're going to put an a in there and solve for a. All parabolas of this form, where a is some number, are going to have vertex 310. They're not all going to go through only 5, -2. Only one of them will. Our task now is to solve for a. So to do that, we sub in the point that we have, which is 5, -2. 5 goes in for x, negative 2 goes in for y. So I get negative 2 is equal to a times 5 minus 3 all squared plus 10. Therefore, negative 2 is equal to 5 minus 3 is 2 all squared plus 10. Make sure you get your order of operations correct here. We get 4a plus 10. We can't add those two together. They're not common or like terms. And then I move the 10 over. I get negative 12 is equal to 4a, or a is equal to, dividing both sides by 4, negative 3. So now I plug that back in, and I get y is equal to negative 3 times x minus 3 all squared plus 10. Now again, we're asked to write the equation in standard form, so I'm going to expand this out. Y is equal to negative 3 times, remember that you need to write two x minus 3's next to each other and FOIL them out. So x minus 3 times x minus 3 plus 10 gives me y is equal to negative 3 times x squared minus 6x plus 9 plus 10. And expanding further, I get negative 3x squared plus 18x. This would be minus 27, and we've got plus 10, so minus 17. And that's my equation in standard form of the parabola that was required. So again, remember that we started from the vertex, plugged it in, and left a vertical stretch factor of a, solved for a using the point that we were given, and then expanded everything into standard form. So there are a couple of examples of finding equations of parabolas given certain information.